Okay, so let's discuss this hot topic with the flattened views. I know we have demo by Josh, yes, some manual implementation by Dan, and probably something else. And the Ryan aggregating all these ideas and probably will provide some summary what we have now.
Yeah, so I was just playing with the syntax that Ryan had shared last week for making views in SQL, and I thought I could take the same syntax and just use it when iterating over an offline ND-JSON file that had never been loaded into a database, and just take in an ND-JSON file and spit out some kind of table. So I made like a very small library with the help of GPT-4 that uses a bunch of JavaScript generators, which I'm totally in love with. And it just goes through some sort of resource generator, which could be a local file or a remote file or anything else that can spit out resources one at a time. And it passes each one through the filters and then extracts the columns from each one. And basically the only kind of interesting bit is for these variables. So like in this example, we're going to look for patient resources, filter them down to female, and then look at the whole contact array. So this performs kind of an unnest on the patient's contacts. And then for each contact, it's going to do an unnest on the telephone numbers for that contact. And then I just threw this in here to have another example of a variable that didn't depend on any of the others. And this essentially just becomes nested loops. So we loop over every possible value of the contact. And then inside of that, we loop over every possible value of the phone number. And then inside of that, we loop over every possible value of the patient identifier. And then for every time we get to the innermost loop, we evaluate these column expressions and we use them to emit a new row of this table. So this is just kind of a quick example that you can play with live in the browser. I'll put the link in the Zoom chat. But whatever expressions you put together here will just get automatically evaluated in the table. And by default, I just have the URL of a very short ND-JSON file with a few rows of patients, but you can point it to your own file or locally select a file with more. And I realized very quickly after I had done this with a larger file that my processing was slow. And then I realized that was just almost all that time was spent compiling the FHIR path expression a gazillion times in the innermost loop. So as soon as I precompiled the FHIR path expression with this JavaScript library, it started to feel very reasonable. So that's the quick demo. And then the repository behind it, this processor.js, which I have running in the browser, can also be invoked on the command line. So if you have a local ND-JSON file and you want to turn it into a CSV output or a table in a SQLite database output, you can just run it with one of these invocations. And it was a pretty good exercise. It caused me to pay more attention to some of the variable names, all kind of made good sense. And it also kind of helped me think through this unnesting model across the variables. I started off with something that was a lot more complicated, trying to do a topological sort of these things, figure out the dependencies, figure out which things to unnest. And then I realized, like, it's fine. This is like in a lot of programming languages, people are used to writing things in a valid order. And if you can't write them in a valid order, there's probably something wrong. So I simplified my implementation.
I know, does JSON parser guarantee that the order will be preserved?
Well, it depends on your JavaScript environment if you want to get technical. But yeah, in the V8 environment, it does.
And what FHIR path library?
I'm just using FHIR path JS. And
so the official one.
Yeah, the official one. And magically, this just kind of works, whether it's in the browser or in Deno. So I've just been playing with that.
Sorry, and hey everyone, this is my first time with the meeting, so I apologize if some of this has been covered previously. But is the recommendation to use JSON path to separate out all the information you want to sort of deserialize into a column? That's my understanding of how you're pulling it all out, right?
Yes, I think that's a question about kind of this overall proposal to use FHIR path to define views, and that's right. You use FHIR path expressions to sort of pull out any subsets of data you need to use in your columns, and then you use FHIR path expressions for the columns themselves.
Yeah, so I'll go ahead and post a link since I think we have some folks that are new to it, like to the sort of the there's a GitHub discussion that goes into a little more depth, and it's evolved a bit since this original discussion, and but this could be like a reasonable kind of context and background. What you'll see at that GitHub link doesn't quite match what Josh showed, because we learned a few things since I wrote up this original Git post. I got a post on GitHub and got from there, but the sort of the TLDR of all that is as Josh mentioned, if we can express each column as a FHIR path expression, we should be able to execute these flattened view definitions across a variety of databases, and as Josh just showed, a variety of technology stacks, like running a JavaScript there. So yeah, so I think it's really kind of the core thesis is like, hey, if we get a portable definition of flattened views that can be used in a lot of places, that would be a pretty useful tool to have in our toolbox. And so yeah, I'm excited to see actually something working in that space.
And great, because the first time, can you introduce yourself? So sorry that I didn't.
Yeah, no, sure, no, happy to. So I'm Gray Faulkenberry. I'm CTO of the startup MayJuun. I'm also co-chair of the Global Health Informatics program at the Children's Hospital of Philadelphia. I have a clinical medical background, and I got into this sort of stuff through global health. I'm interested a lot in low resource settings. That was kind of my introduction. And all my development I do in Dart and Flutter. I maintain the FHIR libraries for Flutter currently. But one of my use cases is having a useful backend that doesn't need the internet. I need to be able to run it locally. And also having a live time database would be really nice. And so I was curious to learn a little bit more sort of about what y'all are doing with this and trying to understand. Databases are not my forte, so trying to learn from the experts.
Yeah, well.
Yeah, so I think kind of going into this, the sort of the mental model is that we had is like I kind of see two parts of this specification. One is defining the view, so basically defining here's all the columns and the criteria that we would select, and that would be pretty much independent of the actual implementation or execution of that view. So like the example Josh showed is a straightforward running against pretty impressive turnaround so quickly, running against JSON files. We have like some experimental stuff that actually translates those into like an SQL query, which would run against a database and that sort of thing as well. But yeah, I think that the key is that if we can have these flattened definitions, we could have multiple implementations that run them over whatever sort of infrastructure makes sense for the specific use case.
And
that's interesting that this flattened view can be used for user interface as well. I just realized so that when you're getting FHIR data and you still maybe need to flatten it. Yes.
I was curious with the FHIR path though. How do you know what sort of end type of data you get from it and how to store it? If it's a single value, you could qualify it as like a date time or a whatever, but a lot of times you're going to get a list or you're going to get a JSON blob from the FHIR path. And then is there a better way to sort of label it or set the type, that sort of thing?
That's exactly the topic we're going to discuss. Yes. So do we want to introduce complex types or arrays or I don't know, some FHIR complex types, or we want to have just primitives? I know that then you did some experiments with the Postgres and binary JSON to manually compiling, or you wrote the compiler?
I was itching to write a compiler, just haven't had time to start that yet. But what I did this week when I was supposed to be doing other work was a couple experiments. So I wrote out two kind of, I think, realistic queries as FHIR path expressions, so we can look at that quickly. And there were some interesting things that came up with that. And then I took one of them, so Ryan converted it into BigQuery syntax, and I converted it into Postgres on a JSON column just to see what that would be. And a couple interesting things came out of that, along with your comment about types, Nikolai. I think I brought that up as well, because I think I ran into the same issue. So I can share my screen if that would be helpful. I don't know if everybody's seen these yet, but maybe it'll spark some discussion too. Let's see. So they're all in the thread on Zulip. I just copied and pasted them while we were talking into text editor. So I did a very basic kind of blood pressure flattening. And I think we've renamed tables into variables now, maybe. And we've used the prefix for that. And then we talked about, the other thing we talked about kind of later in the thread was whether to break out the resource from kind of the unnested portions of it. And I think that, I mean, you can kind of figure that out probably in the code, but I think there's some clarity in separating that out. And then Ryan had proposed we might also want like a filters key, which I like because you can have multiple filters then. And so if we did that, then this might be something like resource as a variable. I think we have to decide if we want to do that.
FHIR already has one like this, which I believe is, I think he used the $. I'll paste it into Zoom when I find it.
Okay, cool. So what does the $sign do, Josh? It's the original, like it's the base resource.
Well, it's just a special character that's used in a few variables that FHIR defines out of the box.
Okay. Sure. So if there's something already there, that would be great.
Well, why not just reduce it to the expression, logical expression? So do we still want? Why not just coding exists? Blah blah blah. Because we want to combine it with some.
Yeah, you're right. We could just do this. You're saying because now we have a separate expression. So yeah, that would work. That's a little cleaner. But we still need the resource reference for, well, I guess we don't, because we could have just assumed everything is based on the resource for the variable. Well, no, because they might reference other variables. It's a little messy.
Well, I think that gets into the variable shorthand. I mean, the use of I mean, so if it's not referencing anything, we could assume that it's the resource, and if it has like the or the percentage sign variable syntax, then that would be it. But.
Yeah, I mean, FHIR does define this stuff. We don't have to make it up. You could write equivalently $this component. You could write observation component, or you could just write component. All three of those would be valid in that context.
I think just component looks nice.
Yeah. I mean, I think just component, I agree that, I mean, that's probably the way I would write it there. But I mean, I think Josh brings up a good point. Like if this is just a FHIR path expression, so I would imagine that that any one of these would be valid. I could type observation component or this component or any of those because it's valid FHIR path. I mean, this is the most concise, so I would probably write it like this. But from a spec perspective, we should just support this with the FHIR path spec.
I think that's fair. I guess we could specify a subset of the FHIR path spec though, since we're probably going to do that.
That's a good point. So, and we definitely should.
I guess it would be nice to I guess I don't see why we wouldn't constrain this. I don't care which one we pick, and we should pick whichever one kind of seems cleanest. But I'd like I feel like if there aren't 3 ways to do it, that makes kind of all the tooling simpler if we're not using an off-the-shelf FHIR path parser.
Yeah, I do think we want to be careful here. Like we can specify a constrained subset, and if we can write the grammar for it, or say we only care about these functions, that's great. But I don't think we want to change the expression semantics. And then, I mean, the nice thing about FHIR path is an expression like this can occur anywhere, and so it becomes like a little bit awkward to try to add additional constraints from outside of our language definition that would say what you're allowed to type inside of that quote mark.
Totally, yeah, I agree with that. I don't think we should support things that aren't supported in FHIR path, but I guess I'm less concerned about saying this is the subset of FHIR path that all implementations have to support.
But we then need join operation for arrays, yes, in FHIR path. I think it doesn't exist, yeah?
Oh.
Can you join array of strings?
You can concatenate.
Okay.
Just with a pipe.
With the pipe, but if it's I don't know, unknown number of elements in array, like classical.
So like the address example we were looking at, right? Like if you have a multi-line address and you want to merge the lines, that was that custom stuff we created? I forget.
No, that I looked that up. That there is a join function that does exactly what we want for the
Okay.
multi-string stuff. And there's also I'm almost certain like set operations that can merge like arbitrary sets of our arbitrary collections of returned items. So yeah, I feel like the semantics of FHIR are quite rich. I haven't actually, everything I've kind of come across is I think there's something in FHIR that meets that need. So I think it is a question of what is the subset of FHIR we want to support, which I strongly agree with like there's some, yeah, we don't want to do it all because that'd be too heavy.
Another one we added, which is not a valid FHIR path, I think, was a get ID function to kind of handle pulling IDs out of references, which I really like as a concept. I think I mentioned this just on Zulip like 2 minutes ago, because it creates, like, if you're parsing JSON directly, then you can just assume that that's going to pull the ID from an absolute or relative URL. And if you're have like the kind of pre-transformed JSON we've talked about like a while back, can handle that. Like, I guess it kind of pushes that to the parser, but this would break our idea of kind of following standard FHIR path.
Yeah,
I don't think it would break it. I mean, FHIR path.
No.
Well, there's maybe two things to say. First of all, you could express this, I think, in FHIR path just using like a split and a last. But FHIR path also has this notion of functions that you can put in context. So like the FHIR path evaluators, you can give them a table of, functions that you want to offer. They're like user-defined functions in a database environment. So if we wanted to specify a couple of our own, like get ID, that we were going to find convenient or useful, we could do that without kind of breaking the FHIR path design.
The official way to define for user-defined functions, like some % sign or dollar sign.
I don't think there's a special syntax for them. It's just you can include extra functions in the evaluation context when you run a FHIR path engine.
I think it's an environment variable, right? You can pass it in, and then you can refer to it using the % sign.
Well, so you can pass in variables, and you can also have an extra set of functions.
But a function as a variable, essentially.
I don't know if that exact thing exists, but those pieces exist.
Yeah, interesting.
Cool. The other thing that I think probably we don't want to do, but it has some things that would make me very happy, is if there was a way to kind of indicate which segments were arrays in the FHIR path expression. So I guess one of the challenges with like building a transpiler for this is it has to know what version of FHIR you're on, and then has to load in all the structure definitions for that version to be able to know what's an array and what's not an array. Whereas like, as you're writing the expression, you do know what's an array and not an array because you're writing it. Plus, different versions of FHIR could technically change that. I think, correct me if I'm wrong. So I guess it would be nice if there was a FHIR path compatible way, and maybe there is, to like in, like a JSON path, you can do something like that to kind of say all the values in the array rather than a specific one. And so if we had a syntax like that, you wouldn't necessarily need to know anything about FHIR to do a SQL transform, which would be a nice property. The one thing I thought you could do, it's kind of an abuse of FHIR path, would be to do something like, where with no filter or something, like have a convention that indicates that something's an array, but that's ugly. So I don't know if we want to do that. And also non-standard, it's non-standard, but non-breaking in theory.
Yeah.
So I don't know if people have thoughts about that. It's kind of, I understand why you wouldn't do it, because again, like the more we can comply with FHIR path, we can use off-the-shelf parsers and kind of move expressions around between use cases. But like, it is a shame that you need, like, that the compiler can't just, or transpiler to SQL can't, it has to have so much outside knowledge.
I ran into the same thing in like the sort of experiments that we did in the Python FHIR path builder that we've been playing with, and I didn't see a good way to avoid the incorporation of outside knowledge without. Even like in the cases of like generating the SQL and the example I've shown, you have to know whether the specific field like is a repeated field or a single field, because you know, whether and so whether you need a nest statement and that sort of thing. So yeah, some type information is there. So so I mean, we kind of like did that by basically including the structure definition information and then propagating it through the translation logic, which did add quite a bit of complexity. And frankly, the code's kind of a mess now anyway, so we need to clean that up. So yeah, I agree that that is a challenge. It may be interesting to see if we can. I would like to explore ways to do that, and maybe in a cleaner or more. Or I mean, I'd be even happy to if there's interest in like an open source implementation of doing this sort of thing, like whether it's in Java or whatever language or a variety of languages to support that. Yeah, I think we should explore that. I mean, the one nice thing about is that, well, one thing I would prefer to avoid is like asking the user to tell us that information. So like in that where example there, it's like, yeah, I think that kind of detracts a little bit from the user experience. They wouldn't expect that. They would need to know that, which isn't ideal. So yeah, so I guess Dan, I'm agreeing with your point. This does add a lot of complexity, and maybe these are things that we can dig into just to see if there's ways that we can address that, or maybe that's a good topic for folks going to the Connectathon next week as well.
One quick question on this, because when we were talking about it on Zulip, I sort of was thinking about it as how do we describe the column types or infer the column types? But I think I'm starting to understand that it's worse than that, because it's the whole traversal all the way to the leaf here. You have to know which steps along the way might require unnesting, as it were.
Yes.
Yeah.
Okay, so asking the user to like annotate each of those seems like it would be particularly onerous.
I mean, so I agree with you to some extent, but I guess like if the syntax was like, you know, put an empty array after the things that are arrays as you write them, like to me that doesn't seem overly onerous. And then like, you know, when it compiles, it knows that it needs to unnest this, and then, I mean, this is obviously not a real example, but like I guess here would be a better example, right? So so this would be would tell it that the coding is an array, and component would be an array. Like to me, that's not the worst syntax, because it tells the user something too, which is that they're unnesting all these values. Whereas otherwise, it's like just from reading the expression, you don't have that context. So I guess, and like you might want to actually have filters wherever you have like an array. And so I guess like to me, rather than being onerous, it kind of conveys useful information to the user as they're reading an expression.
That's exactly the problem we encountered when we implementing the FHIR search in a smart way. So there could be option to include meta information, like just summary of it in this view, which can be deduced if the engine is smart, or can be used by more straightforward engines. Because what we need, so we have to kind of attach array or not array, or probably type information for every path expression. It can be additional key.
Because I actually liked your solution to that, Nikolai. I think we kind of have two issues, right? Like we have the array issue, like what needs to be unnested kind of through the chain, and then the issue of like what your output type is, which again, like you might be able to infer from the structure definitions, but also then you need to parse the structure definitions. And there's some stuff that's ambiguous, like dates, where like maybe you have a date or maybe you have a timestamp, and FHIR might say timestamp, but you might actually, you know, just care about date because your input data is all only at the date level. And I actually thought, and I copied it out, I actually thought your suggestion on that was really good, Nikolai. I'm curious what other people think, but like for a column, I think the idea of like, I like the cleanliness of just having an expression, but I think breaking it into a JSON object seems reasonable, because we, as Nikolai pointed out, like we may want to have description or other metadata associated with it as well. And so if we're going to put in a type, like that seems like a reasonably clean way to do it. But to me, that's different from kind of an array indication. But I'm struggling because the array indication will break kind of compatibility.
In JSON path, they use sharp to denote array. So you write dot sharp dot something.
I kind of like the idea of empty brackets, because if you put a number in there, that's standard FHIR path, right? So you're already handling brackets with something in it after an array anyway. And so,
But I'm not sure this is a valid FHIR pass expression.
Right, they're not currently.
no,
Yeah.
but I mean, but if you had component bracket 1, right?
That would be.
That would be legitimate FHIR path. So you're already handling brackets after an array anyway, or you can in standard FHIR path.
Yeah, if there was a slice syntax in FHIR path, like in Python, or you know, you could stick a colon in there or start and end bounds, but it's not, you know, not the current FHIR path language.
There's all sorts of characters we could use. One of them, Nikolai, correct me if this is wrong, because you're the expert on JSON path, is it or JSON pointer? I always get them confused. One of them has an asterisk, right, for full arrays.
Probably yes, but usually they use sharp.
But nobody supports it.
Dot sharp, yeah.
Okay.
I haven't seen asterisks.
Like
I've
the
seen
word sharp,
a negative,
or like
sharp sign. Sharp. No,
Like
no,
that,
like a symbol.
Like a hash.
hash,
Okay,
okay,
C sharp.
got it, oh, I see, like C sharp. Got it now. Okay. The brackets are closer though to existing FHIR path because of the indexing.
Another way to have a meta information near to that, so you can say that the component is array, and inside component, I don't know, coding is array, and then pass this into the context. But yeah, everything not perfect.
Yeah, I mean, or maybe there's a way to pre-process or structure definition, or because I mean, all that information is really it's all there, right? It's like there's a it's defined, and then each FHIR path. I mean, the FHIR path expressions themselves, it's like we'll define. I mean, based on their input, you know what they will produce as an output. You know, so like first, if the result of that dot first there is always going to be 0 or 1 items, and that sort of thing. Yeah, so I mean, I guess I would like to, before we go down the path of adding annotations, I would like to explore and see if there's ways that we can pull it from the structure definition, so we don't kind of place this on the author of these things.
Yeah,
because basically we're asking the user to provide the information, like the type information, and know the type information, and it may not always be obvious. Like if somebody's like sitting down and just experimenting in an interactive setting like what Josh had shown, I think maybe they just want to build that.
On the other hand, so I take your point, and I think we should explore that. I do think that there is something nice for users about knowing about kind of including this, and often like it's hard for me to imagine somebody writing a FHIR path expression without looking at either the resource or an example of the resource. So I'm a little torn on that, and I guess the other thing is like I did this many years ago for a different project where I parsed the structure definitions and tried to create the list of items, and it gets a little bit complicated. You probably know this, Ryan, from having done it with the complex types. So you kind of have to, you can't like enumerate every possible path ahead of time and just have a lookup that's easy, unless you like really limit your nesting, and also that becomes huge. So you kind of have to like store like your complex type part of the path, and then kind of do a second lookup and put those in, and that can, for something like identifier and reference, like that's infinitely recursive. So you kind of have to cut that off. Like you have to be able to do that on the fly, ideally. So it makes the whole compiler piece or transpiler piece like way more complicated. Even if you like pre-process the structure definitions, you still have to do some of that at kind of the time you're doing the transformation. Yeah,
I think this is definitely an area to dig into in more depth. So the approach that we had taken, like in our little experiments in this space, where basically, would take the FHIR path expression, then use Antler to put it into a tree, and then basically as part of that tree is that there's always a root, so we can look up like the type of what's the type of the field on the root, and then we just add that to each node in the tree. And so basically at every one of these items, we know exactly that we know that the type and we know the cardinality, and then kind of so it bubbles up there. So it didn't turn out to be, now I want to reference our implementation code because like this is just screwed around, but I think from an algorithm perspective, it didn't turn out to be terrible if we take an approach of because we have to have like the FHIR path expression parser anyway. We have to build that basically expression tree of FHIR path nodes anyway. And so then it's a question of adding type information to each node in that tree. And which you know, when you look at it as like a whole, the whole problem space seems daunting. But when you look at it like, oh, I'm at the root node. I know this is the code function. I know the type of my code function. Okay, add it to that. Then I type, you know, then, oh, and now I'm at the coding step. And so my parent is a code. So I get that type and add it to that point in the tree as we build it. So yeah, I think this is something we probably need to sort of sketch out in more depth. But I don't want to,
Namebox, we're doing something similar. So we call it annotated FHIR path expressions. So we're parsing and adding the meta information as well. We have a simplified index of all the meta information, like huge JSON object where you can look up by path. If you go through the FHIR path and keeping the path, then you can quickly look up how many arrays and what the type.
Yes, I was talking less about kind of the annotation part, which I think once you have a syntax tree, it seems like, you know, like just kind of maybe complex code, but like straightforward. But I guess more about like, what do you have to extract from the structure definitions to be able to do that? And it turns out like you need a fair bit of, like, it's a pretty large array that you're pulling out of there of like the type information that you need to be able to do this. So, which like not a problem, but I guess it implies that the transpiler is going to have like be able to load the full set of structure definitions for each FHIR version that you may be parsing. Or maybe
to be honest, it is very small. So when we throw away all this meta information, we just keep the arrays information and type information. It's like a zipped file is like 4 kilobytes. So for basic, so and lookup is very fast. So potentially it is not a problem. So we can invent kind of lightweight structure definition distribution, which can be used by engines.
Okay, so then would we also need a key for like FHIR version here, right? Because that information is tied to the version.
So I think that's an interesting topic. So for what it's worth, I'll tell you what we did in our experiment, so we can decide whether that makes sense carry on elsewhere. So using this model of separating the execution of the view from the from the definition of the view, you definitely need to know the version at the execution time, because you know that's all the type version. In the definition of the view, we found like there's quite a few views that can run on multiple versions of FHIR, and so it's nice to have those portable. So I could see if we did annotate this, I would have one is like definitely support multiple versions in that, and we could even consider whether we want to make this optional, and basically if it is optional when we run it, then we will just like the execution engine may reject it, saying no, this doesn't match this. Your FHIR path expressions are bad. It doesn't match this version of FHIR. But I do like having this as an optional annotation to show, hey, what versions this supports.
Okay, so it sounds like we probably want to experiment with kind of how this looks on the transpiler side, and also maybe think about whether we want to include like syntax for this, although again, like because it's breaking, it seems like something we might not want to do. It would be nice if there was a way, if we got it into the FHIR path spec and it was just ignored otherwise, because like I guess, you know, almost like a comment type of annotation that, you know, some compilers could require and others would just ignore. But anything else we want to discuss about this example? I guess the other thing I put in here, which we can decide if we want to include in our subset, is I think we hadn't talked about exists. We'd only talked about where, and I ended up using exists in this example in 2 places. One is here, which I think could also be a where. I guess I'm a little unclear because that would return a value, which I think would evaluate to true in some FHIR path parsers potentially. So we could maybe we don't strictly need exists in this use case, although since we don't care about the value, it's probably the more correct syntax. And then I also used it for whether or not there's a data absent reason, with the thought that like in the output view or output table, like the user might want to filter out blood pressures that have a data absent reason, but they might not. And so they might want to look at that. So putting that in as a like exists value. I guess the other option would be if we didn't have exists, we could populate a JSON object into that column and then just query about whether it's null or something, something there. So I guess both of these are kind of weak examples, so that it's like nice to have there. I don't know if it's critical. So I guess curious, like if we want to add that to our, if there's a reason to add that to our subset, or if we just keep using like where or outputting things that could be a Boolean, but also could just be a value.
I think we need exists, particularly when you start dealing with this ternary logic where something could be empty or unknown in addition to true and false. I think there's really no other way to say that in FHIR path.
So that's one that we probably want to add.
One small comment, maybe let's introduce namespaces for view names, not just one identifier, but something through the dot, or I don't know, closure style, Java style namespaces. My namespace pressure is blah blah blah.
Are you thinking just for like categorization, or are you thinking it would end up in the database as something like a schema or
you mean
something?
So yeah, that's interesting idea. Yeah, but just for the naming, I would introduce a namespace so you can no name clash.
I think this whole JSON object that we're looking at between line 1 and line 27 is part of some metadata package, maybe that's publishing several of these thing, would have a namespace and authoring information and so on. But I don't know if we can pack it all into the view.
And this is kind of local name, yes, the view.
Yeah.
I guess I was thinking that these would be in some sort of directory structure, maybe with package names, like an NPM sort of thing.
Yeah.
So that you can have like a set of views for kind of creating a base for calculating quality metrics, and a set of things for like, standard health system operation analytics and like other stuff. And that you might put the same view in multiple of those, but like, I agree with you in that like we probably need like layers on top of this for categorizing these and sharing though.
This resource is going to be stored, or we can introduce another attribute, which is called namespace. Yes, so if all these view definitions are stored in a database, so you can kind of add an optional namespace attribute, which may be pre-filled from folder name or something like this.
Yeah.
Because it's usually always too late to introduce namespaces when you understand that you need it. Yeah, this mapping to the schema is interesting as well. Yeah, because I think a lot of databases have the notion of schema.
Yeah, and if you have a set of kind of related tables, you might throw them all into a single schema so that they don't conflict.
And honestly, if I mean, as a user of this, I first of all, I think that the views themselves, I agree with like packaging them up in some sort of namespace and some external package. I mean, if I'm a user of this, I might want to put that package in a different database schema. Like I might have Ryan's test schema and have all my views from that package and that. So I think like an unqualified name here and considering a qualified name in the package, and let the implementer put that and put that package in the schema of their choice, which may be the same as the package name, but it can be up to them. Okay. Yeah, thanks for adding these open questions to the doc, Dan. I was trying to
I'll throw them somewhere else. This is not saved at all, but just let me know if I'm
well, we're recording this as well, but so maybe maybe it's worth like trying to jot these down, and I'll catch the recording and obviously coming out of this, there's going to be a list of open questions that we'll need to work through. But we'll see if we can collate those and put those either on the GitHub issue or on the Zulip.
Yeah, that sounds good. And maybe I think a lot of us will be at the Connectathon next weekend, so it might be a good time to like really try some prototyping around these and see where we land. I guess I want to take, since we've spent a lot of time on this, I want to take a time check. Like do people keep talking through examples or switch to something else?
I think Craig just brought up a question in the chat there, which actually I think is probably a good topic. Like there's a question around basically the semantics of multiple arrays and what happens when you bring them all together. Yeah, so I think we have a working idea of what that looks like, similar to well, I mean, using maybe Josh's example of where like each array was essentially like each array is like looped with the parent, but if there's like multiple trees in that, like I think the semantics that we had is those would effectively be like a cross join, but we need to be pretty concise on those those semantics. So if you expand an array of like, I mean, so I'm trying to think of a good example. I don't know if you have like a patient and you expand like address and you expand contact point, like in the same view, that probably doesn't make a lot of sense to create a view that would expand both of those. But if you did, then you basically have a cross join between address and contact point. But yeah, I think that, yeah, but I do think like the variables and unnest and cross join semantics is something we need to be crisp about. And probably a good follow-up question there too.
Yeah, maybe we could put some examples in the spec of like what the output tables for what we expect the output tables to look like in different scenarios.
So yeah, so actually into I mean we can start writing those. And does this group have like a preference on if like starting to take some like really raw drafts of some of those? A model that I find works well is like to have like a collaborator, like a very rough collaborative doc, and just start putting this stuff in form and like adding examples, and people can comment and add those. I don't know if there's a preference in terms of that. I mean, I'm happy to create like a Google Doc that we can share and that sort of thing, but I'm not sure what the preferred, if there's a preference.
Yeah, let's go with the Google Doc. I think that's okay.
Google Doc's okay for me as well, but Josh points out hackmd.io is what we've been using in Argonaut, and it has the nice property of not garbling your code or kind of and having everything in Markdown, so then you can pretty easily migrate it to GitHub at some point.
Okay. Okay, cool. Yeah, I'm not familiar with that. Let me take a look at that. Yeah, I can appreciate the if you have a lot of like code examples, which we probably would in this, like a Markdown syntax, makes sense to me. Yeah. So yeah, I'll take a look at this, but I'm fine with using this as provided assuming we can easily collaborate and comment and that sort of thing on it easily.
Yeah, so it has comments, and also you can have multiple editors and kind of all the things you would expect. You can sync it to GitHub and other things.
If we do use it, I would almost suggest we don't use their explicit commenting feature and just write comments as notes in the doc, because their commenting feature is not great compared to Google Docs, but the collaborative editing does work just fine.
Should we talk about the other example? And then I think maybe next meeting we want it, or at the Connectathon. I don't know. I'm not able to meet next Friday. I don't know if other folks are. But we could also talk about some of the SQL that Ryan put together and that I put together, which I think might be an interesting discussion. But I think it's almost like the first layer is to agree on like what we're trying to represent in SQL, and then talk about like how we represent it and how that maps. At least that's how I think about it. This example is good, but it's a little bit too easy, I think, in some ways, in terms of like extensions add a lot of complexity, particularly because you have different extension types, some of which are nested and some of which aren't. And so I wanted to do one. I thought it would be worthwhile to try an example that is a little more involved. I can convert this to the syntax we're kind of closing in on. But there are a couple things in here that I think are worth discussing. First of all, there's the shorthand syntax for extensions that Josh introduced me to, which I think is pretty nice. So this is the equivalent of like where URL equals, but when you have a lot of extensions, it's just a nicer way to do that, and definitely a lot more readable. So I think that's good. So here I'm unnesting the OMB race category extension as a nested table. I guess we're calling these variables now. And then in the columns, there are a couple things here that are interesting. So I put in an OR, which I wasn't sure if we were supporting or not in our FHIR path subset. So I guess that's a kind of an open question, whether we're supporting Booleans to connect kind of parts of an expression.
I don't see the reason to not support OR. because it can be expressed in SQL, yes, quite
Mhm.
major.
Yeah.
Yeah, I mean, so this line in particular, for example, like we could, if we wanted to have a very narrow subset, we could force this into 2 columns and let people do this kind of calculation at the next level of SQL after the flat. I guess it didn't seem like it added a lot to our existing semantics. So I thought having the ability to do something like is this in kind of inline seemed nice. I'm for like keeping the ors and being able to do at least some kind of simple transformation as part of this. But obviously this is like a deep rabbit hole we could go down. Like the more you allow, the more transformation you do in the flattening, like the more complicated your FHIR path is going to get.
It's almost like a judgment call in terms of like, is the value added by including the expression justify the complexity of implementing it? So in cases where the complexity is quite low, which I think as Nikolai was referring to, in this case, it seems like the complexity is pretty low for adding OR and the value is reasonable. So I would also be supportive of including OR expressions that, but yeah, maybe we just kind of use the sort of the heuristic of, hey, if how much value does it add for does the value added justify the complexity cost when we consider how we would implement it? And for me, the answer here is yes, and that others may have different perspectives, and certainly in other cases, the answer will be no.
Mm-hmm. And extension URLs are quite noisy. Yes, if we could at least put it in variables that make it much more readable. So you can define like race URL variable and then reuse it for ethnicity. So I think the FHIR has support this, yes. And the question to us, can we use variables in functions? I
guess the question is like, do we want? So I like that idea because I also think these are like very long lines and not easy to read. Do we want to have the ability to define constants as part of your variables or in a separate key? And this object's getting very complicated.
Yeah, let's discuss it in the chat or in the GitHub.
Sounds good. I noticed Evan has his hand up. Evan, do you want to take the floor?
I just want to ask a question. So the intent here then, if I already had tables in a schema in a database and I wanted to use this type of mapping to create views and I want to do all of that within the database, is the intent that I would take these expressions in the columns from, like line 43 to line 55, these are FHIR path expressions. Would the intent be that I use a FHIR path to SQL translator to be able to create the scripts that would do these mappings for me? Is that what we're thinking, or am I completely confused?
Yeah, I think that would be one possibility here for sure. You run a script that reads in this structure and outputs something tailored for your database that you can evaluate when you see fit. There may be other more integrated ways to use this, but I think that would be one option.
Okay.
Yeah.
Okay, that was my other question.
Oh, yeah, so just to add that, and I'll pass it back to you for your other question. But yeah, in fact, that's basically the approach that we've kind of been exploring is like take a view definition. And then we found like a pattern that we find really works very well is to like take like, say, this patient demographics definition we have there, and then just translate it to like a literally create view statement. So depending, most databases have like the notion of virtual tables. And so this translates to a create view statement, you save it to your database, and then you no longer need to even touch this definition because it's just a table in your database now. Everything plugs in nicely. I think that pattern works well. But anyway, pass it back.
Yeah, good. I just want to make sure I'm understanding this, and it sounds like I do. So great, thank you guys.
So I think we're right at time, which is a shame because this is kind of fun. It'll be fun to talk through more of this, but I guess we'll have some time, hopefully next weekend, to do that.
I tried to write this subset Antler grammar for FHIR path. So everybody welcome to review it if you have experience in Antler. So please help us. Because I think it's important to have this kind of restricted set of FHIR paths so we understand that it will work. Okay, guys. So thank you, everybody. So see you, most of you in New Orleans.